This video will discuss the communication of scientific claims in the media, such as news or social media, and the stance of skepticism towards those claims. We often see scientific claims communicated in the media, such as drug A has a significant increase in effectiveness over drug B, or new research shows that adults need less than 8 hours of sleep. But what do these claims really mean? Should we be skeptical of these claims? This video will give a bit of background on how these claims are communicated from research to popular news. 2. Discuss how psychological beliefs and biases impact how we process information. And 3. Finally, it provides suggestions for how we should regard these claims. I will suggest that we should be skeptical of them, but not so much that we outright reject them all. It's a common phenomenon that we're often bombarded with scientific claims in the media. We have our TikTok, Facebook, and Twitter feeds that can distribute scientific research claims. We can hear it on the radio or see it in the news, and we read new claims in blogs and websites. But what's the deal with these claims? It can be hard to accept new information that contradicts our prior information, so it's not wrong to have some amount of skepticism towards scientific claims that goes against our prior beliefs. It's no wonder we can be skeptical about these claims, which can lead to broader scientific skepticism. If science keeps making contradictory claims, why should we trust science? It might help us to talk a little bit about the communication of scientific claims in the media. How are these claims communicated? The claims we see in the media are very dilute and layman ways of translating scientific research into easily digestible information. Science is a process of using specific methods to boil down nature to easily analyzed factors. When we do experiments, we end up taking naturally occurring phenomena, that's things that happen in nature, and we break it down into numbers. After breaking it down into numbers, we end up with very specific raw data. On this raw data, we do certain statistical computations, and then from these computations, we get specific mathematical values. These specific statistical or mathematical values tell us if we've got the right to say that a variable under one condition is increased or decreased from another condition at better than chance. Basically, this number tells us from the statistical computation on the data if there's a significant effect that isn't due to just chance. When we see a better than chance increase based on these calculations, we can say there's a significant effect or significant increase or decrease depending on if the value goes up or down. And this is what significant means. Significant means that there's a better than chance outcome that the effect that we saw occurred. However, we can then claim, for instance, that drug A is significantly better than drug B. However, even if this is only a 1% increase in effectiveness, which translates to negligible real-world effects, if it's significant, then it's an increase nonetheless. Now that I've explained a little bit more about how the scientific research process goes and how they make their claims, I'll now discuss why these claims get diluted down. So scientific experiments often use very specific methodologies, numbers, statistical computations, etc. And these computations are not relevant or interesting to the layperson. The layperson won't be able to interpret what these mean. For instance, some of the formulas that they use are pretty big. They've got it's a mathematical formula. It comes down to numbers and symbols, but a layperson, unless they have studied statistics at, say, a college or university level, won't really understand what an R value is, for instance, or a P value, which are values that determine whether we can say that an increase is significant or not. Now, on the part of news outlets, they want to bring the reader very accessible and digestible claims and information. For instance, when you see the headlines, usually they're like 6 to 7 words, and they have to sum up the research, and then maybe you get a couple sentences about researchers at the University of Berkeley found that this effect occurs. Complex research, which has many variables and complexities, are boiled down into like one sentence claims, and so the layperson doesn't really understand raw research, and the news outlets makes I guess what we'd call a dumbed down version of the research, and this becomes how popular science is disseminated. There's a lot of factors to consider and specific caveats that often come with sort of scientific research. We really need to consider it as a claim with an asterisk beside it. When you see those news outlets, you have to take it as drug A is significantly better than drug B. For instance, the claim might only apply to a specific sample of the population. An example is if the research only investigated primarily white males, or in a sample of the population, such as in the US, where it's primarily white males that live there. So this is how research is translated from observations and experiments in the world to what we see in the media. On to the second part of this video, I'll talk about psychological biases and how we mentally treat information. Another issue that contributes to scientific skepticism pertains to how we think and our mental biases. So we all have our set of our own values and knowledge. When we get new information that contradicts or updates our current worldview or our values, it can cause a sort of a friction with our knowledge. When we get one claim that we hold as true and another one that says that one's not true and this one's true, then we sort of have to fit this in to our knowledge, or rearrange our knowledge structure. This takes time and effort. So what do? Do we accept the new claim and rearrange our values and knowledge, or do we reject the claim and keep the current knowledge structure? In this case, where we get new contradictory information, we might get an instance of what we call cognitive dissonance. Cognitive dissonance is the mental toll that contradictory information has on us. It's basically psychological stress when we need to choose some value or belief based on information of roughly equal weight. One thing of note is that some scientific claims are seemingly contradictory. I'll explain what this means by using an example with butter. We might see one scientific claim that says margarine is healthier than butter because it has less saturated fats. But then, at another time, another claim that butter is better than margarine because it doesn't have trans fats. So, what do we do with this information? Do we consider using both spreads now? Keep using just margarine? Or switch to using just butter? Here we have mental stress because this claim impacts our real world choices. If we've been using, for instance, margarine because we thought it was better for us, and then better for us because we saw it as a scientific claim, and then we see another scientific claim that says new research finds that butter is actually better. Then we have friction. We have to do something with this information. We can ignore the new claim, keep the old claim in our set of values. We can incorporate the new information, rearrange our eating habits. It's not really clear what to do and which claim to trust. And this is why we can be skeptical towards science and think that science is always unsure of their claims and provide contradictory claims. We can lose trust in science, and this makes us more skeptical. What makes this even worse is that both claims might be true in some sense. However, they may be true in relation to specific factors. Perhaps a diet in saturated fat is bad for most people, but not everyone. Perhaps trans fats in one's diet is not good, but only after a certain amount we've eaten. So we could probably tolerate a certain amount of trans fats. Now, should we take this information as meaning that butter is bad, or maybe just a diet in high saturated fats is bad, not the butter itself? Can butter be incorporated into a specific diet? However, what we don't realize is that science is not done in complete unity. Research is done in groups in relation to a common method. One set of researchers might have different experimental conditions than another set. Scientists don't really consider how their information fits into current knowledge. They just report on raw observational facts based on experiments. When one scientist reports something, it's in relation to their own specific controlled experiment, which might look at butter and not just margarine. Of course, they are looking at prior research or taking that into consideration. Often that informs the experiments, but experiments done in different labs can show different effects. All right, so I hope that wasn't too confusing. I'll give a little recap here, so let's take a stake of what we've discussed so far. Scientific claims we see in the media are dilute versions of raw data made to appeal to lay people. I would suggest that if one wants to know the whole story of a scientific claim, is to get some scientific education, know how that works, how science works, and read the actual research article that the claim comes from. We can also experience cognitive dissonance when we experience contradictory information from two or more scientific claims. We often don't like changing our beliefs and values. Doing so brings us mental stress. From this stress, we can be skeptical that science really does have knowledge and truth. But if science keeps making contradictory claims, why should we trust science? My suggestion is that one carefully consider the sources of both the research to determine the details of how each scientific claim applies to your particular situation. Again, this involves diving deeper into the research. We should also consider that each fact is itself true in a specific context. We need to know what this context is. What sample of the population does it affect, etc. As for skepticism, I don't condone outright rejecting all scientific claims. Science has some credibility and it works. It has shown that it has real world applicability. However, we do need to think critically about scientific claims and their truth. What you see in the media is not the whole truth. We should be skeptical, or at least skeptical in a critical fashion where we have the capacity to probe a claim further. A drug that is better is sometimes only marginally better, and it may only be better for specific sorts of persons, not everyone. Further, our prior knowledge sometimes has difficulty in accepting new evidence. If we get new information that contradicts prior information, we may just think that the source of these claims, science itself, is not credible. So, I thank you for taking time to listen to this video. I hope it's been insightful in how scientific claims are communicated in the media, and how we can be critical in thinking about these and not skeptical when we get contradictory claims. So if you've liked this video and you want to see more content like this, then of course subscribe, and if this video was helpful, give it a like. Keep learning and stay educated.